Hey guys, I'm going to help you all out with number 4 tonight. There have been some questions about that one. So we're talking about the independence of events. And in this case, we're dealing with a situation where we have a 15% chance that a person in NYC, New York City, grew up in New York City. There's a 34% chance that a person in New York City uses the subway as their preferred mode of transportation. So we've got A, the event that they grew up in NYC, and we've got B, the event that they prefer the subway. If the percent of the NYC population who both grew up in NYC and prefers the subway is 8%, are the two events dependent on one another? So we're going to start by making a Venn diagram. We've got our group A and our group B. All right, so we'll say this is B, this is A. And what we know is that the population who does both is 8%. And this is where most people are making their mistake, because a lot of people are writing 34 here and 8 here. The problem with that is there's a 34% chance that a person in New York uses the subway as their preferred mode of transportation. In this scenario, you've added 8% to that. So this is a 42% chance of people in New York using the subway. So the problem is you can't put that 34 there if you're going to put the 8 there. So instead of putting that 34 there, what we're going to put there is 34 minus 8, because that's the ones that are here that are not also people who grew up in New York, right? So this is the group of people here who ride the subway and did not grow up in New York. This is the group that do both. And we have to do the same thing over here, right? Because we've got a group of people, 15%, that grew up in New York. 8 of them also choose to use the subway. So we've got the difference of that in this section over here. So this should be a 7% chance of growing up in New York but not riding the subway. So now that we've got an accurate Venn diagram, it says if the percent of the New York City population who both grew up in NYC prefers the subway is 8%, we did that, are the two events dependent on one another? So we've got to do our test. We've got to check to see, is the probability of A equal to the probability of A given B? And we've also got to check to see the opposite. Is the probability of B equal to the probability of B given A? This is our test for independence. So the probability of A is going to be 15 out of all the people in New York City. So 15 out of 100, or 0.15. The probability of A given B is going to be out of all B, so out of these 34% people, how many of them are also in group A? So that would be 8 out of 34. And if you do 8 divided by 34, you should end up with 0.24. So those are not equal. Now, we know that it might not end up being perfect, but those aren't too close. If they were off by like a couple hundredths, then I might say we go with it. But these are 0.09 away from each other. So that's a big enough difference that I'm right now not willing to admit that they're independent. But let's check the probability of B and the probability of B given A. The probability that I get something in B is 0.34, because there's 34% of the people in New York who ride the subway. And the probability of B given A, that's going to be of all the people in A. So of the 15 people in A, there are 8 of them who grew up in New York City. So 8 divided by 15 gives us 0.53. And since those are not equal and those are not equal, we cannot say that these are independent. So the question is asking, are the two events dependent on one another? Yes, they are. All right, so that's it for number 4. Hopefully that helps you with the rest. It's pretty much the same concept. You're going to keep using this check in every problem. Good luck on the rest, you guys. See you tomorrow.